Today we're going to solve quadratics by using the quadratic formula. Okay? This is something you've learned before. However, you really have to pay attention to understand this. Okay, remember, a quadratic equation is written like this in standard form. Ax squared plus bx plus c equals 0. A is the coefficient of the x squared term, b is the coefficient of the x to the first term, and c is your constant value, the one that doesn't have a variable beside it. Remember the other day, on Friday, we were working problems that did not have a bx term. And when that happens, you're able to solve them the easy way. It's called the square root method. But some quadratic equations have a bx. See how in all three of these examples down here, they actually have the bx term in all of them? So today you're either going to factor it or solve it by using the quadratic formula. Obviously factoring is the easier of the two, so you always want to start by checking to see if it can be factored. So let's look at A. When I say can it be factored, I mean are there two numbers that multiply to give you a positive 3 and add to give you a negative 4? Are there?
Yes.
What numbers will do that? Right. A negative 3 and a negative 1 multiply to give you a positive 3, but when you add them, you get a negative 4. You also need to put x and x so that when you're foiling, x times x is x squared. Okay, so all we've done so far is factored. We broke it into two different factors. We haven't solved, and today we're going to be solving. To solve this one is simple. All you do is take each of your factors and set them equal to 0. Okay, so eventually you'll just solve these without even writing it down. To solve this for x, what do you do to both sides? Right. And so your first solution is, right, a positive 3. For this factor, what do you have to do to solve for x? Add 1. And so your second solution is positive 1. Let's talk about why those are the solutions of this quadratic equation. If I go to the calculator and I type in this quadratic equation of x squared minus 4x plus 3, but I'm going to replace both x's with my first solution of 3. So 3 squared minus 4 times 3 plus 3. See how I've just rewritten what's over here, but in the x places I'm plugging in my first solution of 3? If 3 really is a solution to this equation, what should I see on the calculator when I hit enter? 0. And I do, so that means it works. Now, remember, instead of retyping it all in, I can just go up to it and hit enter, and it copies and pastes it. And now can I just replace both of those 3's with a 1 to see if 1 is also a solution? Okay, so when I hit enter, I get a 0. That means these are the two solutions. Now, there's another reason they are the solutions. Look what happens if I graph this quadratic equation. If I graph x squared minus 4x plus 3. How many times does it cross the x-axis? And doesn't it cross it at positive 1 and positive 3? So that confirms that these are the solutions. We did it algebraically by typing it in and making sure it was equal to 0. And we graphed it and saw that it crosses the x-axis at 1 and 3. Okay, B. Is the equation for B in standard form? No. What's wrong? Well, it's not set equal to 0, right, Kiara?
Yes.
Doesn't this negative x belong, like if this is the standard form, this is your ax squared, this is your c. Isn't that your bx? So doesn't that belong over here between the two? So to move it across the equal sign, what do you have to do to it? Add it. It'll cancel over there, giving us 0 like we wanted, and when we add it in over here, it just goes right in between them. 2x squared plus x plus 1. Okay, now that it's in standard form, now you look at it and you say, can I factor it? But how is this one different from the one we just did? Right, it has a leading coefficient of 2 instead of just a 1. Now, there is a possibility that it can be factored. You've never learned how to factor a quadratic equation with a leading coefficient greater than 1, but maybe we could graph it and see. Okay, I'm going to graph it. Y equals 2x squared plus x plus 1. Okay, does it ever cross the x-axis? No. So we're not going to try to factor it. We're going to solve it using the quadratic formula, which is right here. You learned this last year. Well, what you see in this formula is a bunch of a's, b's, and c's. So don't you have to kind of know what a, b, and c are for this quadratic equation? What is in the a place? Remember, the a is the coefficient of the x squared. So wouldn't that be the 2? And what's the b? 1. Isn't there an understood 1 beside that x? And then what's the c? 1. Any questions so far? Now what we're going to do is we're going to rewrite this equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I rewrote the quadratic formula, but I left a bunch of blanks. And why did I do that? Right, we're about to fill it in. What goes in the b place? 1s. So right here and right here are going to be 1s. What goes in the a place? 2. So here and here we're going to have 2s. And then what goes in the c place? 1. Okay, now you're not going to type it all in. Okay, you're going to type in one thing at a time. The first thing we're going to type in is everything that's up under the radical. Not the actual radical, but everything up under it. That's called the discriminant. Okay, so that 1 squared minus 4 times 2 times 1 is called the discriminant, and that's what we're going to type in first. So 1 squared minus 4 times 2 times 1. And what do you get? A negative 7. Okay, so now I'm going to rewrite this as x equals, in that negative 1, you can just drop the parentheses, right? Plus or minus the square root of negative 7 all over what? 4. At this point, I'm going to break it apart. I'm going to put the 4 under that part and under that part. Now, let me show you why it's not a good idea to try to type in the radical. You know how I told you not to type in the radical, just type in everything up under it? This is why. If you had tried to save yourself some time, you would have just run into a problem. It would have given you an error. Why do you think it gives an error? What did we get when we typed in all the numbers up under it? A negative. Can the calculator take the square root of a negative number? No, because it's complex. Aren't we just going to make that negative an I on the outside? So x equals negative 1/4 plus or minus I square root of 7 over 4. At this point, you would look and see if you could reduce the fractions, and you can't, so you're done. Okay, as soon as you're done copying that, I'm going to erase it so I have room for C. Is this one in standard form? No. What's wrong with it? Why is it not? Right. This is your C, and it belongs over here right after the 2x, correct? How are you going to get it over there? Right. And when you subtract that 1 and then subtract it over here at the end, then it equals 0 like you want it. So we have 4x squared plus 2x minus 1 equals 0. Okay, also something I didn't mention with the last problem, but doesn't it make sense why it ended up not crossing the x-axis when we graphed it, because your answer was complex? Let's go ahead and graph this one and just see what it looks like. 4x squared plus 2x minus 1. Okay, so look, for this one, we have real solutions, don't we? Okay, so that'll make more sense once you see our final answer, why you actually see two places that it crosses the x-axis. All right, the first thing we need to do is identify the A, B, and C. What is the A? B? And C? Okay, then you're just going to plug into the formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, what am I going to plug into the b places? 2, so a 2 goes there and a 2 goes there. What about the a places in the formula? 4. And what about the c? Negative 1. Now the first thing I want you to type in is the what? Which is called the discriminant. Right, so let's type in that discriminant. So 2 squared minus 4 times 4 times negative 1. I would always put parentheses kind of like I wrote them in. Okay, you'll never go wrong with parentheses, but without them you could go wrong. 20, okay? So now I have x equals a negative 2 plus or minus the square root of 20 over what? A. So at this point I'm going to go ahead and break those and put them under each. Now with the previous problem, didn't we end up with the square root of 7? So 7, like, you couldn't factor tree it as prime. I mean, if you tried to, it would be 7 times 1, and there'd be nothing to circle. So everything would have gone back in. So that's why we were done. But what about the square root of 20? Can we simplify it? What are its factors? And then that breaks down into a, right, so circle, fill a 2, kick out a 2, 5 goes back inside. So didn't this square root of 20 just become 2 square roots of 5? Okay, you could maybe rewrite it over here, but I'm going to just to save room, I'm going to replace it. Because we have one more step after this. Does anybody have any idea what step I'm referring to? Right. Can't we reduce negative 2 over 8 to what? Right? And then plus or minus. Positive 2 over 8 is also 1 over 4, but you don't have to write that 1 out there. It's understood. I mean, you could, but you don't have to. So, that should be a 4. Right there. Okay, so that would be the final answer. So now, did we have an I in this answer? No. That's why when you graphed it on the calculator, you actually saw it touch the x-axis in 2 places. Now, if you zoomed in on where it touched the x-axis, you'll see that it's not going through a whole numbers, right? That's why your answer looks like this. Like when we did this one, didn't I just go through it whole numbers? That's because we had whole number answers. But over here, that's why you have to use the quadratic formula, because your answers are not whole numbers. Okay, let's look at one more before I let you try some on your own. Okay, number 1, is this one in standard form? No. What do I need to do to get it in standard form? Right. The 9 belongs right over here, right after the 9n. So that'll be 6n squared plus 9n minus 9 equals 0. Okay, then I need to identify my A, B, and C. What's your A? B? And C? Right? And before I even continue, I'm just going to throw it in the graph real quick, just so I know ahead of time, is it going to be like a complex number answer or a real number? So 6x squared plus 9x minus 9. Does it cross the x-axis? Yes, but neither one of them crossed at a whole number, right? So that's why we're having to do it this way opposed to factoring. But that also lets me know I'm not going to have an I in my answer because it crosses at 2 real spots. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, what am I going to place in both of the b spots? Right? What about the A spot? And C. Right? Now when I start simplifying, what do I type in first? Right, which is called the discriminant. So 9 squared minus 4 times 6 times negative 9, 297. So x equals negative 9 plus or minus the square root of 297 over what? 12. And at this point I'm going to go and break it apart. That way when I go to reduce, it's easier. Now, the square root of 297, is it a perfect square? How do you check it? You just type it in, right? And if it's a whole number, it's a perfect square. If it's a decimal, it means we have to do what to it? Right, factor tree it. Now, obviously, you're not going to be able to do yours where I'm doing mine. Just find somewhere on your paper, wherever you have room, to do the factor tree for 297. So, what are your factors? What numbers multiply to 297? Any ideas? 3 and 99. Okay, that would work. Okay, and then 3's prime. 99 breaks down into 3 and 33, right? And then those 3's just drop, and then 33 breaks down into 3 and 11. Now that they're all prime, you circle any pairs, kill one of the pair, kick the other out, and then what else going back inside? 33. So 3 times 11 goes back inside, right? Yeah. So now this square root of 297 becomes 3 square root of 33. And so technically you have your answer here. It's just not in simplest form because both of those fractions can be reduced. What is 9 over 12 reduced to? Negative 3/4. Remember, for those of you who have trouble reducing, if you just go to alpha y equals n over d, type it in whatever you're trying to reduce, and then it will reduce it for you. Okay? Alright, what about 3 over 12? What does it reduce to? 1/4, right? Well, you don't really have to write that 1. You can, but you don't have to. And so there's your final answer. So we have real answers. There's no I. That's why we saw it touch the graph 2 times. It's just that it crossed the x-axis at decimal location, so that's why your answer looked like that. Like if you typed all of that in, it would give you a decimal value that matched up with what we saw on the graph. Okay, why don't y'all go ahead and try number 2 by yourself. Okay, so number 2, what's the very first thing we have to do? Right, this 12 belongs on this side of the equal sign, so we have to subtract it to get it over there. So 9n squared plus 4n minus 12 equals 0. Did everybody at least make it through that step? Okay, now we need to do the quadratic formula. You could go ahead and graph it just to kind of have a heads up whether it's going to be a real number or a complex answer when you do it. So 9x squared plus 4x minus 12. Okay, so we can see that it's going to be 2 real answers. There's not going to be any i's. Okay, so let's identify the A, B, and C first. What's the A? The B? And the C? And then you just plug them in the formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2 times A. Then you just plug in the stuff where it goes. So both of these are B's. What goes in those? 4. Both of these are A's. What goes in those? And then this one is C, so negative 12. The first thing you're going to type in your calculator is the discriminant. So that's 4 squared minus 4 times what? Okay. And I get 448. Okay, so this right here becomes a 448. Okay, what does this right here become? 18. And now, is the square root of 448 a perfect square?
No.
So what are we going to have to do?
I did 7 and 60.
7 and 64? Okay, that'll work. So we can start with those. So I'm sure many other combinations you could have started with. And that becomes 7 times 8 times 8. And then 7, that becomes a set of 2's, that 2 drops, that becomes a set of 2's, and that 2 drops. So the only thing going back in the house is the what? 7. You have 3 pairs. So how many are getting kicked out? 8. Remember, you multiply them. 2 times 2 times 2 is 8. Another thing you could have noticed when you start getting good at these, when you get to this line and you have a prime number and 2 8s, that kind of lets you know that's going to be your pair. Yeah, you broke them all the way down into 2's, but didn't it just end up killing 8 of them, kicking out 8 of them? And the 7 went back in? Okay, so now we bring down the rest. I'm going to go ahead and put the 18 under each. So will that reduce? Negative 2 over 9.
Well, 4 over.
4 square root of 7 over 9. Is that what everybody got? Okay, so watch. I'm going to type in these answers. So alpha y equals negative 2 over 9. First, I'm going to use the plus sign of the answer. Plus, now I'm going to type in the second fraction. 4 square roots of 7 over 9. And that gives me 0.95. Now I'm going to type it in with a minus. So instead of typing that all again, I'm just going to copy and paste and replace that plus sign with a minus. And my second solution is negative 1.39. So 0.95, negative 1.39. Doesn't that look about 0.95? And that looks about negative 1.39. So see, that means you did it right. Okay, go ahead and try number 3. Okay, I have something for you. What do I need to do first? Right, this 12n, girls, belongs over here. So that'll become 5n squared plus 12n plus 12 equals 0. I then identify the A, B, and C. What's the A? What's the B? And what's the C? Then guys in the back, be quiet. X equals negative B, so that would be negative 12, plus or minus the square root of 12 squared minus 4 times 5 times 12. Hold on, I got to figure out. Well, whatever.
Stop touching stuff. Look what you did.
I'm just going to have to write the plus, or the other 12 right here, okay? They're right out of room. All over 2 times 5. Guys, we are not done. Close your mouth. So now that becomes x equals negative 12 plus or minus the square root of what? What did you get when you typed in the discriminant?
It's not negative 12.
Why not? Negative b would be a negative 12.
But both of them is negative.
When you move that 12 in across, it changes signs.
What?
See how your bx term was over here, so you had to move it over here? Okay, what did you get up under? Okay. All over 2 times 5, which is 10, is 96 a perfect square. What did you get when you factor treated? 332. Let's do it real quick. What are the factors of 96? How about...
Is 12 and 8 not a factor?
Oh, I don't know. I wasn't listening
Yes,
to you. 12 and 8?
Yeah, Jay, why you saying like that?
12 and 8. And then that becomes 3 and 4, which is a 3, 2, and 2. And then 8 is a 4 and a 2, which is 3 2's. I know I'm doing it quick. Okay, so circle, circle. 6 is going to go back inside. And what's getting kicked out? 4. 4. However, it's negative, so you have to put an I. And then will those reduce? Yes. That will reduce to whatever what? Right. And that will reduce to whatever what? I squared to 6. 4 divided by 2 is, Okay, now, since there's an I in the answer, what does that mean your graph would look like if you graphed it? It will not cross the x-axis because you have a complex answer. Okay, listen.